For example, structure of monosaccharides. The structure of monosaccharide can be explained on the basis of different formulae. Number one, Fisher's projection formulae. Fisher projection formulae are used for straight chain monosaccharides when monosaccharides are in the straight chain, not in the ring form. For example, pentoses. Pentoses D-ribulose, D-ribulose and L-ribulose. This is the structure of D-ribulose. This is the structure of L-ribulose. There are two asymmetric carbon atoms. 1, 2. This one, this one, this one. These three atoms are not asymmetric carbon atom. This one, this one, this one. This one and this one. Both are asymmetric carbon atoms. Now, this is carbon number 1, 2, 3, 4. This is 4. This is 3. So this is a numbering. This is highest numbering asymmetric carbon atom. It is farthest from the carbonyl group. This is 1, 2. This is at position 2. 1, 2, 3. This is at position 3. So this asymmetric carbon, the configuration of this asymmetric carbon will be considered to compare with glyceraldehyde. So in glyceraldehyde, when the hydroxyl group to the right side, so the glyceraldehyde is said to be D-glyceraldehyde. So the same case over here in case of this structure. So this structure is actually the structure of D-ribulose, while in this case the hydroxyl group to attack to this carbon atom which is farthest from the carbonyl group. Here are two asymmetric carbon, 1, 2. This is number 2. This is number 3. This is farthest from this carbonyl group comparatively to this one. So this will be considered for the comparison to glyceraldehyde. So the hydroxyl group to the left side, so this is L-ribulose, just like L-glyceraldehyde. The same case over here in case of D-ribose and L-ribose. This is the farthest asymmetric carbon atom in case of ribose, this one. So the hydroxyl group in this case to the right side, so this structure of ribose is said to be D-ribose. The hydroxyl group in this case to the left side, so this is said to be L-ribose. Hexoses. In hexoses, the example of glucose. Glucose is found in two different isomeric form, D-glucose and L-glucose, with respect to this farthest asymmetric carbon. And glucose, there are 1, 2, 3, 4 asymmetric carbon atoms. This is carbon number 2, 3, 4, 5. So the carbon number 5 is the farthest carbon, asymmetric farthest carbon atom from carbonyl group. So this carbon will be considered for the comparison with glyceraldehyde. So to this carbon, the hydroxyl group is attached to the right side. So this structure of glucose is said to be D-glucose or D configuration of glucose, D designation of glucose. And in this case, the both structure are same. The difference is over here at carbon number 5. Carbon number 5, there is a hydroxyl group is attached to the right side, while in this case to the left side. So this structure of glucose is said to be L-glucose because it is similar in this portion configuration with L-glyceraldehyde. Another example of hexose is fructose. So in fructose again there is 1, 2, 3 asymmetric carbon atoms. So this is carbon number 1, 2, 3, 4, 5. So 3, 4, 5. 3 carbons are asymmetric. This is nearer to carbonyl group, near to carbonyl group. This is nearer to carbonyl group. This is farthest from the carbonyl group. So this asymmetric carbon will be considered for comparison of configuration of fructose with glyceraldehyde. So you can see, in this case, to this asymmetric carbon, the hydroxyl group is attacked from the right side. Attacked to the right side, so that's why this is called D-fructose, as in the case of D-glyceraldehyde. While in this case, the hydroxyl group is attacked to the left side of this for this asymmetric carbon atom, so this structure of fructose is said to be L-fructose. Both structures are similar. You can see similar. Only difference is on the basis of this carbon, carbon number 5. This is different. Hydroxyl group to the right side. In this case, to the left. To the right side, D form. To the left side, L form. With reference to D-glyceraldehyde and L-glyceraldehyde. This structure is similar in this portion to D-glyceraldehyde. This structure is similar to in this portion to the L-glyceraldehyde. So there are many monosaccharides, tetroses, pentoses, hexoses, heptoses, and they are represented by DL designation or configuration. Their configuration will be considered, will be matched with the glyceraldehyde, which is used as a reference sugar. This is all about the D and L designation or configuration. Thank you so much for watching this video. For more videos, for more updates, stay tuned with us. I am Ubaidullah Shah, lecturer in chemistry, Government College, Madian, Swat. Goodbye. Allah Hafiz.